Hi guys, what's up? Welcome to our channel Turbo Electronics Experiments. So first of all, I want to wish all of you Happy New Year 2023. And from today onwards, I have already told in my last video that from today onwards, we are going to upload some experiment based video or some videos on making some gadgets or doing some projects, that is electronics based projects. Similarly, today's video is upon one of these projects. In today's video, I am going to build a blinking LED circuit using 555 timer IC, or in more specifically, you can say any 555N or any 555P timer IC. See, when I am going to tell you the blinking LED circuit, so there are three ways you can build it. First one is through microcontroller, that is Arduino based blinking or ESP32 based blinking or Node MCU based blinking. Even you can use PIC or any type of microcontroller for blinking one single LED. Obviously the LED I am going to use is operated on 3 volt. That is a 5mm LED or maybe a 3mm LED. So this was the first process. Second process is using relays and some values of capacitors. And the third process is that I am going to build here today. That is any 555. Basically, there are some advantages when I am going to use a 555 IC for building a small blinking circuit. Even I am going to tell you one of its very important advantages than the other method. That is its cost. Its cost is so less that you can't imagine. So there are three advantages upon building all the project on any 555 timer IC. First one is its cost. Its cost will be less than the other two methods that I have already mentioned. And the second one is its size. It will be tiny that you can use this circuit in any other projects or any other gadgets where blinking or LED blinking is required. Third one is its power consumption. This power consumption is very less and you can even use a small 9-volt battery and which will keep it continue up to 5 to 6 hours. So you can immediately understand that what is its actual power consumption. And there is another one advantage, that is its efficiency. If you use relay, then there will be some noises which will be irritating. If you use Arduino, so their delay will not be accurate. But if you use timer IC, there will be accurate pulse which will be generated by the timer IC and accurate blinking delays will be generated. So that will look cool. So that's why I am going to build this project using timer IC. And from this video onwards, I am going to follow each and every steps that I have already mentioned in my last video. That while doing a project, while building a gadget, while building your own circuit, you have to follow 7 steps. So guys, if you haven't watched this video right now, so I am going to recommend you, all of you, to watch that video first, so that you will understand what is the benefit of following all the 7 steps. So from today onwards, while I will make some video on some gadgets or some project, I will obviously follow all the 7 steps. So without wasting any more time, let's jump our video. I have completed the first 2 steps, that is finding the components along with their model number, and I have also made a list along with their prices also. So let's jump into our third step. fast and let us check what happens. You can see here, as soon as I have run this circuit in the simulator, my white LED is blinking as well, and the blue indicators and red indicators are indicating the ground and the positive terminals. The red indicators are indicating that the current is flowing to the LED, that means a voltage, that is 3 volt voltage or whatever the voltage is maintained across the LED a particular time interval. The time interval is produced by this IC as well, and the blue terminals are denoted as the ground terminals or the negative terminals of the battery. And with this, our circuit simulation part is completed. Now it's time to primary or the temporary assembly in the breadboard. Let us do it now. So before starting the breadboard connection, you have first to understand the number of pins and the pin numbers of this IC. So pin numbers that you already have seen in the simulator, it not exactly same in your real world. The pin number, for determining the pin numbers, for determining the first pin, that is pin number 1, and to determine the last pin, that is pin number 8, and each and every intermediate pins, you first have to identify the notch of this IC. In 10555 IC, you can see that there is a notch. This is the notch. Thus there is a small cut mark, and the left pin, just left pin of this cut mark, that is this pin of this cut mark, this pin is the pin number 1, and the right pin of this cut mark, that is this pin is the pin number 8, and the pin number are sequentially as 1, 2, 3, 4, 5, 6, 7, 8. That is the U structure. That is, again I am repeating, that is the pin number 1 is the just left pin of this notch. That's why you first have to find out the notch. So if you are able to find out the notch, then the leftmost pin, that the just left pin of that notch is pin number 1, and then pin number 2, then the pin below that is pin number 3, then the pin below that is pin number 4, then pin number 5, 6, 7, 8. That means 8th pin or the last pin is the right pin of the notch. After determining it, you just have to do connection referring your connections that you already did in the simulator. And in simulator, in the IC, the pin number has already mentioned. You just have to do connection in a breadboard like it. I am going to use this breadboard. This is a small one breadboard. You can use any breadboard for it, and I will connect each and every components in this breadboard along with the IC. So let us do it first. And I am not going to show each and every connections here, because I am just connecting all the components referring my connections that I did in the simulator. So you can also do it. It's very easy, not too much complicated. Let us do it first. I have made the temporary assembly of this circuit that I already designed in the simulator. According to the circuit diagram or according to the connection that I made in the simulator, I have designed this circuit in the breadboard. Now I am not going to give you the detailed circuit diagram in the breadboard right now. You can easily make this circuit according to the connection the simulator. I will put the link of the simulation and as well as the picture of the circuit diagram in the Google Drive, and I will put the drive link in the description below so you can check it out. I am just give you a small details what to do and how to do. So here is the LED. It will start blinking as soon as I will give the power supply here. This red wire is denoted as a positive supply will be connected to here. The black wire is denoted here for the negative supply, which will be connected here. The supply that will be connected here will be within the range of 9 volt to 12 volt, and for this I am going to use my DIY power supply. that I already made in my own home. And for here I am giving 9-volt DC power supply. This is a portable power supply. This can be varied from 0 volt to 12 volt, and you can draw any kind of voltage from 0 volt to 12 volt. So that's why first turn it on, and first I will set the voltage. Now it is showing 7.85. I will set the voltage to the 9 volt at first. So let me set it. So it is now set at 9.09 volt, which we can assume that it is approximately 9 volt. So after setting it, I will turn the power supply off right now and connect the red and the black probes of the power supply to the red and black wires as well. So let me connect it first. You can see that I have connected the red and black probes of the power supply to the red and black wires. That's why that means that I am giving 9 volt supply to our NE555 IC. So let me just turn on my power supply. Yep guys, as soon as I turn on my power supply, you can see that the white LED that I put it in my breadboard, it starts to blinking. And from now you can understand that the circuit that you have made here is completely okay. By the way, for connecting each and every components, I have used single threaded wire. You can also use jumper wires as well. Okay, there is no issue. For singles, I just generally prefer single threaded wire because the single threaded wires put tight in the breadboard. The jumper wire sometimes become loose, so there will be the issue of loose connection. That's why I always prefer single threaded wire. So as my circuit is blinking, as my LED is blinking, so that I can assure that my circuit is performing well. And as my circuit is performing well, that means my fifth step is done. Now I am going to jump my sixth step, that is I am just reassembling all the circuits here, all the components, each and every components that has been put here, and I will assemble and I will join all these components permanently in the PCB or in the breadboard through soldering. So let's jump to the sixth step. As you know that we have already made a temporary connection in the breadboard also. So and we have already completed the 80% of our project. Now I will keep removing each and every component one by one from the breadboard and keep attaching each and every component in this breadboard. And again I am telling you guys that I am not showing you each and every connections, otherwise the video will be very long. So if you want to refer my connections that I have already given you in the description, then you can refer, otherwise you can make it on your own. I will do this connection according to this connection that I made already in the breadboard, and as well as these connections and these connections will be similar to the connections of the Proteus Suite simulator connections. So you can refer it. Guys, I have made the connection in the breadboard finally, and I have used here the minimum number of wires. In maximum cases I have used the direct soldering, and I have tried to solder the components with each other directly, so as if any kind of error occurs later after the final connection, I can just simply debugging it without any harassment. So I have put this LED here in this style because I am going to use this circuit in my later on project. So that's why I will not complete my 7th step because I will not put any enclosure for this circuit, as I have already told that I will use this circuit in my later project. These two terminals or these two wires are positive and negative wires where you have to give up 9 volt to 12 volt power supply to operate this. And for better insulation, later I will put a hot glue here, because you can see that here so many weldings, so many solderings that I have did. So the solderings may short with each other, so that's why for better insulation I will put the hot glue. Now it's time to testing the circuit. Now let's test it. For testing the circuit I will again use my DIY power supply again. This is my DIY power supply, and I will set 9 volt after turning it on, and you can already see that it is already set at 9 volt. So let me now connect the props of the negative to negative and the positive to positive, and after connecting it, as soon as I will turn my power supply on, the LED will start blinking as well. So let us check it now. Yeah guys, you can see that as soon as I have turned my power supply on, the LED starts blinking. I will just put some hot glues here in this area, not in this area. Make sure that don't put any hot glue upon the IC, because otherwise the IC will get hot, and hot glue temperature remains around 200 degrees centigrade. That 200 degrees centigrade the IC cannot bear, that's too much temperature, so that's why that IC may burn out and your total circuit will get damaged. I will put hot glue here only in this side where I have made the maximum soldering, so as to avoid the internal short circuiting and so as to give a cool look here. When I will use this circuit in my later project, then there will be less chance of short circuiting. And for Vero board, I have cut a small piece of Vero board from a big Vero board, so as to avoid much space. Okay, it will consume very less amount of space. You can see here the size of the Vero board is actually the size of the circuit is. Okay, now it's time to put some hot glue here. Let me put it first. Now I have put the hot glue here, you can see, and while putting the hot glue in the back side or in the front side, sometime it may occur then you have to put some hot glue near the ICs as well. So while putting hot glues, make sure that your IC is removed from the base. That's why I have used a base here that I have already told in the beginning of the video. So I have used a base so as to make this IC removable. So I have first removed this IC and then I have put some hot glue. Now the glue has become cold and it has become hard. Now I will just insert my IC and I will check this circuit again. Now I will insert my IC in the base carefully. Yeah guys, my IC has been inserted in the base carefully. You can see here I have inserted my IC as well. Now it's time to check this IC, this circuit once more. Before checking this circuit, I will use my DIY power supply again, and I will set the voltage at 9 volt that it has been already set here, and I will connect the black and red props with the black and red wires of this IC, of this circuit, and I am giving 9 volt supply here, negative to negative and positive to positive. And after turning it on, you can see here that our circuit and our project is performing well. So guys, hope all of you enjoyed this video. If you like this video, then you can smash the like button, and for these types of more videos, if you want all these types of videos, you can subscribe our channel, so that as soon as I will upload a new video, you will be get notified soon. That's all for today. Thanks for watching. Keep learning. Till then, bye.